Dividing complex numbers. We're going to divide 10 by 3 minus 4i. And just like when we were dividing radicals, when we are dividing complex numbers, we're not truly dividing. We're just changing the form of the number or form of the expression so that we don't have an I or a complex number in the denominator. When we're doing this, we're going to be multiplying by a form of 1 using the complex conjugate. So we need to find our conjugate. We need to look at our original denominator, which is 3 minus 4i, and our conjugate will be 3 plus 4i. We still have our 3, we still have our 4i, but the operator in between them is the opposite of what it was originally. So our conjugate is 3 plus 4i. And now we will multiply by a form of 1 where we have this complex conjugate in both the numerator and the denominator. So I have 3 plus 4i in the numerator and 3 plus 4i in the denominator. So now let's multiply. In the numerator, I'll have 10 times 3, or 30, and then 10 times 4i, so plus 40i. Okay, now in the denominator, I'll have 3 times 3, which is 9, 3 times 4i, which is positive 12i, negative 4i times 3, which is negative 12i, and negative 4i times 4i, which is negative 16i squared. So let's start simplifying. Right now our numerator will stay the same, 30 plus 40i, but our denominator we can combine some like terms. We see 12i and negative 12i. They will combine to form a 0, or they'll cancel out. So I have 9 minus 16i squared. Now we need to remember that I squared is equal to negative 1. So we have 30 plus 40i in the numerator, and 9 minus 16 times negative 1 in the denominator. Simplifying further, we have 30 plus 40i over 9 plus 16, because negative 16 times negative 1 gave us positive 16. Okay, so simplifying further, we have 30 plus 40i over 25. Okay, so now we need to put this in complex number form, which is a plus bi. And the easiest way to do that is to separate this into two parts. So I'll take 30 over 25 plus 40 over 25i. And now we can simplify these fractions more easily. 30 over 25, we can cancel out 5s. 30 divided by 5 is 6. 25 divided by 5 is 5, and that reduces to 6/5. And then if I look at 40 over 25, I can again cancel out 5s. And 40 divided by 5 is 8. 25 divided by 5 is 5. So I have 8/5 I. So this simplifies to 6/5 plus 8/5 I. Let's look at a second example. Let's look at 2 plus 3i over 1 minus 4i. And let's see if we can formalize these steps a little bit. So first, we will multiply by a form of 1 built from the conjugate of the denominator. So first, we need to find the conjugate of the denominator. So if we're looking at our denominator, that's 1 minus 4i. The conjugate will be 1 plus 4i. So we still have the 1, we still have the 4i. The operator in between them is the opposite of the original. So now let's multiply by a fraction where both the numerator and the denominator are the conjugate, 1 plus 4i. And now we'll multiply. So we have 2 times 1, which is 2. 2 times 4i, which is 8i. 3i times 1, which is 3i. 3i times 4i, which is positive 12i squared. Let's multiply the denominator. 1 times 1, which is 1. 1 times 4i, which is 4i. Negative 4i times 1, which is negative 4i. And negative 4i times 4i, which is negative 16i squared. Okay, let's combine like terms. So in our numerator, okay, we have 2. And then we have 8i plus 3i, which combine to form 11i. Remember that I squared equals negative 1. So this I squared is negative 1. And we have 12 times negative 1, which is negative 12. So I have minus 12. And then in my denominator, I have 1. I have 4i and negative 4i, which combine to form a 0. So they cancel out. And then I have I squared again, which again is a negative 1. Negative 16 times negative 1 gives us a positive 16. Simplifying further, in the numerator I have 2 plus negative 12, which is negative 10, plus 11i. And in my denominator I have 1 plus 16, which is 17. And then we'll put in the form a plus bi. So let's separate into two fractions to do this more easily. So I have negative 10 over 17 plus 11 over 17i. And these fractions don't simplify. So this is my final result. Negative 10 17ths plus 11 17ths I.